Okay, so this is the first video of many, I hope. What we're going to do is we're going to start out with chapter 14. So, and this is day 1. Chapter 14 is about probability. It's a different math than what we've been doing so far. It's the odds that things are going to happen, the probability certain outcomes will happen. And so the first day is filled with some vocabulary and some formulas, and so let's take a look at the first one. Probability. If you read it, it says the chance of an outcome happening after many trials. I know sometimes we think of probability, the probability I get heads on a coin is 1 out of 2. That's what we think. That's theoretical probability. In reality, probability is the chance that it'll happen, and we find that out after doing many trials. So for example, let's say I had this duck, and I wanted to flip the duck in the air and land it on the table. How often will it land duck head up versus off to the side? The probability that it lands duck up, head up, is what I get after I do many trials. So if I drop this many times, whatever it is, that's the probability of it happening, not because someone says that it's what's going to happen. So there's theoretical probability, and then there's real probability. Okay. Another vocab word that we use is random, and we talked about random in the beginning of the year. It's when you know what the possible outcomes will be, but you don't know what will happen next, and we already talked about that. This next one's new to us, and it's called the law of large numbers. And what it says is the following. In the long run, after many trials, the probability of an event happening will get closer to the true probability of that event happening. And so, if I take a coin and I flip it, and I say, well, I got tails. And I got tails again. And I got heads. And then I got tails. So 3 out of 4 were tails. That's 75%. This coin might initially not work out to be what we think it is, which is 50%, 50-50, heads and tails. But after many trials, the law of large numbers will tell us that the probability of getting ahead, if that's our event, will get very close to the true probability of that happening, to that true theoretical probability. Okay? So sometimes we might do an event only a few times, and it might not give us what would really happen in the long run. So this is like, in the long run, what would happen. That's the law of large numbers. Try not to confuse that with what's called the law of averages, is what you're, you know, when people say, oh, they're due to make a free throw because they've missed 3 in a row, that has nothing to do with the law of large numbers. Because we know every time we flip the coin, each flip is independent. The previous trial had no impact on the next, but we know that in the long run, eventually it should work itself out to be whatever the theoretical probability is, or whatever that true probability of it happening. So with the duck, I might flip it a couple times, and it might land ducky side up, it might land ducky down, but if I did it 1,000 times, whatever the true probability it is, and we might not know what it is, but it would start to get close to whatever that true probability is happening. I know you did probability earlier on in your school years, and there are some formal probability rules that follow, all right? For any event, and we'll just call the event A, we know that the probability of A happening has to be between 0 and 1. 0 is it can't happen. 1 is it definitely will happen. So let's say event A is to get a 7 when I flip my coin. What's the chance I'm going to get a 7? Nothing. There are no 7s on this coin. It's heads or tails. So that's a 0 probability. Let event A be get a head or a tail. Look at that. Every time I'm going to get a head or a tail. 1. So the probability of A falls somewhere between 0 and 1, and it could also include it. The complement of event A. So this word here is complement. It's an important word. The complement of event A is the set of outcomes that are not in A. And we use notation A with a little c, meaning A complement. So for example, I roll a 6-sided die and let the event A be the numbers 1 and 2. So I have a dice, 6-sided, I roll it, all right? Event A will be the numbers 1 and 2. The complement of A, which we write as A with this little C up here, is everything not in A, but still I could get when I roll my die. So the other things would be the numbers 3, 4, 5, and 6. So event A, I roll a 6-sided die, is the numbers 1 and 2. A complement would be 3, 4, 5, 6. Let's talk about weather. It's either rain or it doesn't rain. The probability it rains might be event A. A complement would be the probability that it doesn't rain. Okay? We can figure out the probability of A. And if A is getting a 1 and a 2, well, there's 2 out of 6 sides, or reduces down to 1/3. A complement then is everything that's not that, 4 out of 6. These two together should always add up to 1. All right? So if you know one of the answers, 1 minus the complement would be the other answer. All right? So if you subtract one of your probabilities from 1, that would give you the other piece. Okay? Next, we have a word called disjoint, or also called mutually exclusive, excluding, leaving out something. Disjoint, away, apart, okay? Events that have no outcomes in common. They have no outcomes in common. Those events are called disjoint, or also called mutually exclusive. All right? So, in earlier grades you made Venn diagrams, and what was in the middle of a Venn diagram was always what they had in common. Well, if events are disjoint, then you would have no data, no answers in the common area. So if no data is in the middle, then the events are disjoint. So when we start making Venn diagrams, if nothing happens here in the middle, then they don't have outcomes in common. Those events would be disjoint, or we would also call them mutually exclusive. Next, the addition rule. And you guys had the addition rule in earlier grades, but we're going to recap it again. The probability of A, and then this little symbol U means or. B happening. A or B happening. Well, it's the probability of A happening plus the probability that B happens. But you have to subtract off all the things that are in A and B together. All right? So for example, I draw a card. So I have a deck of cards. I have a deck right here. Okay? Here's my cards. I draw a card, find the probability I get a heart or a queen. So I'm going to pick one out. I got the 2 of clubs. But a heart or a queen. Okay? So you have to let event A, B get a heart, let B get a queen. So A or B, according to our rule, is going to be the chance that I get a heart plus the chance that I get a queen minus the chance that anything is a heart and, that little symbol there means and, an heart and a queen. Well, let's think about it. In a deck of cards, there are 13 cards that are hearts. Okay? In a deck, there are 13 hearts. There are 4 that are queens. But notice, the queen of hearts is counted here and here, so we must subtract off the 1 card. All right? This 1 card that is a queen and a heart. We have to subtract that. So our answer is 16 out of 52. If I told you to take all these cards, pick out the hearts and the queens, and you counted them, you would have 16 total cards. You would have 13 that are hearts, and the queen of hearts is there. You would have 3 other cards that are queens. You would have the queen of diamonds, queen of clubs, and queen of spades, total 16. All right? We could do it in a Venn diagram. Let this circle be all the queens. Let this circle be all the hearts. All right? Let me just see if I can move this down a little. There we are. So, we know that there is 1 card out of 52 that is the queen of hearts. They share that. There are 3 queens out of 52 that are queens but not hearts. And there are 12 cards out of 52 that are hearts, but they don't share the queen in common. So when we add all these up, we get 3 plus 1 plus 12, and that is a total of 16 cards. All right? On the outside of the Venn diagram is anything that's not in here. And there are 36 other cards out of 52 that are not queens or hearts. So, if someone asks, are these events disjoint? It's another question they could ask. We would say no, they're not disjoint because they have outcomes in common. And you can see it here, they have outcomes in common, or you can see it here, they have outcomes in common. So a question that they will ask you on your AP exam, are these events disjoint? And you can find your answer by the fact that they have outcomes in common noted here, or outcomes in common noted here, not disjoint. Something else we're going to talk about is the multiplication rule. All right? If events are independent, then the probability of A and B happening is just the product of those two happening. Okay? So, draw 2 cards from the deck. Pick 2 cards. All right? Find the probability you get a queen and then a heart if you replace the cards. Notice, that makes a big deal if I replace. So, I shuffle them up. All right? I need to get a queen and then a heart. Okay? So, I draw a card. Look, ooh, I got a queen. What's the chance I get a queen? 4 out of 52. All right? What's the chance I get a heart? Here's a heart. 13 out of 52. So, if I draw 2 cards now, I'm not drawing 1, I'm drawing 2. What's the chance I get a queen and then a heart? Notice, I get a queen and then a heart. I didn't say queen or a heart, I said a queen and then a heart. Well, here's the chance I get a queen, here's the chance I get a heart. I multiply them together. 4 out of 52 times 13 out of 52 turns out to be about 1 out of 52 if you reduce your fraction. All right, 0.09123. Now, the problems at the bottom are problems that we're going to work on in class, so you don't need to do those for homework. All you had to do is just get these notes down, and tomorrow when we come into class, we'll go over the notes and have any questions, and we'll work on some problems related to this. Okay? Enjoy. Thanks.